Baguettes! Nah. Alright, I guess we're starting here. Uh, yeah, there we go. Anyways, we're gonna get started with coding the game engine here. I should actually left share the screen here. So last time we were left off, we created logging with SPD log. This stream, I want to get a window up and running, and then hopefully get some Vulkan stuff implemented. Maybe just abstract the windows for now. But anyways, let's start with the application abstraction, I guess. Let's go straight Twitch. But anyways, we're gonna go to our core and make an application here. What do we need? Struct. I'm not gonna make it a struct. I'm going to just make it a. Ha. There goes Officer 401. Class. Alright, so. We're gonna create a new application class. Private. Public. Private. And this basically will have the whole entire application lifetime in of itself. Um, so what I'm going to implement here, we're going to have a void virtual void update float delta. This would be our update loop. Void init. I'm gonna have these two as pure virtual. So we have to implement our initialization code and our update code. And our render code. So yeah, so we initialize, we update, we render. That's our main code. Application. I'm not gonna make that pure virtual, but we need to have a destructor somewhere. I'm gonna just set it to default, I guess, for now. But our application would also have layers. So what layers are, if you check the chair now, is basically it renders or determines the order of rendering. So I like that different order of rendering. So I'm gonna implement layers too here. Layer. Anyways, we're gonna have a void in it, virtual void. Pure virtual. render and a virtual destructor. Render. So yeah, this basically entails our layer. Um, but yeah. So in the private members, we want to have a few things. First, something to hold our layers. So std vector layer. I think I called it. Yeah, just layer. Rename. Include that here. Layer.http. So we're going to have our like layer, and I'm gonna have this as protected. Oh. So basically we have a list of layers, and that's what we're gonna do and initialize. Well, update all the layers and then render all the layers pretty much. What separates the application from the layers is that we pretty much can like keep the application as a single run function here. So this is like common for all void run, and basically it automatically does the init update render for us. We can obviously, or we can do override it if we want, but for the most part, that's pretty much it. Um, we do want to have a window handle later. But yeah, that's pretty much what we have so far. Let's implement something here in Sandbox. I'm not gonna put in a namespace since this is our sandbox. We may wanna do this later, but nothing much. We do need to implement this run function for our application. So what I'm gonna do is in the source, new file, application, run. So basically this is going to call our init function. And yeah, I'm gonna put a running function. So while we're running, we're gonna this update and this render. And this is basically our main loop here. So back in the application, we're gonna have a bool running, and we could have a helper function here. Inline bool is running. It's gonna be a constant. And there we go. Um, when we do initialize, we want to set this to true, and then have some handle to say, nope, you're no longer running, turn it off, and we exit. That's pretty much it. Um, we don't need to override it for now. This is good enough. Um, so we're gonna do a initialize. This is over. Void update. And we're gonna override all three functions here. And then in our sandbox, we're gonna do a test application. That's how you mess up. Is trying to fix your typos. I just don't know what I did there. Formatting, include tell. All right. Let's bring up chat here. All right. So we initialize, update, render. I'm gonna just when we initialize, I'm gonna do the logging. So include got HTTP. GE log init. Oh, world. Percent 2.2f, I guess. Delta. And there we go. So let's try to make this. So since we added new files, Premiere 5 gmake. I bet we get errors. Or yep. I forgot to put the namespace. So that's all good so far, which is quite good, writing that much code and getting that few errors, but it's gonna get complicated pretty soon. Um, so back in our sandbox, we're gonna include our test application here. We can get rid of that. Include test application. And I'm gonna allocate this on the heat. And KE application pointer. Let's see here. An expected type specifier before test application. Um, I guess just test application now. Not declared. Eh? Oh wait. What? Test application at HPP. It should have copy and paste this. Error. Test application was not declared. Oh wait, it's test app, isn't it? Yeah. Yep, there we go. Now if I run it, um, it's updating just fine. I'm not gonna worry about that. I just wanna see if it just don't need to update. I want to see the hello world. There we go, the hello world, and we quit. All right, we got something going here. All right, so we have this application working, which is a plus. We got a test app or an application of which has layers later on. But what else that we need here? Oh yes, I want to get this update working. Um, SPD. formatting. So we can have formatting here. Right. So it has different text, I think. Percent default format. Really, it's a plus. Okay. Um. Actual text to log. Thread process logger's name. Short log message. I wonder if we can add like plus floats. Oh wait. All right. So instead of percentage F here, we can just do and then make it so it's not like a sprintf or printf. Delta time. So with delta time now, this is going to be implemented in the main function. We're going to use the chrono library. Uh, time. So we need to get our current time, so auto now equals std chrono I think std chrono high resolution clock, and then now, yep, that now return a time point, and then auto current equals chrono, high resolution clock, now, and then at the end we do an auto, or now equals current. And then when we do our difference here, duration, std chrono duration of, would be later. It'd be like that, I think. Um, um, duration float, time now. That's I already saw that. Okay. STD, chrono, duration, wait, duration, current minus now. Duration float. I think it's that now. Yes. So yeah, this is pumping out at 100% CPU, I believe. If I do an HTOP here. Yes, 100% CPU. 50% CPU. It should just. Or not enough CPU. I don't know. Uh, but yeah, that's pretty much it for that. We got our update loop working with the time. And yeah, what we can also do to test this out is to, in the test application, we can do a threaded sleep. Sleep 4. And I'm gonna use using namespace. Let's see, Piano patrols, I guess. Zero point 0.01 seconds. And that's pretty much it. We're just sleeping for like a little bit, but so it doesn't tax the CPU that much, but can't tell a difference. But yeah, that's pretty much good. I'm going to comment that out just in case I need it for something else. But we got our application layer working. So I'm gonna commit here. All right, so we got our application working. What else? We want to have a window. So this window's gonna be using GLFW for the time being, but we want a way to abstract it out so we can use Win32 API or Hoka, I think, for Mac, or use Qt, whatever, for Linux. But GLFW is a good general abstraction of all three operating system. So we're gonna create a new file here called window.hap. Pragma once. Include pch.hp. Um, so there's going to be a general consensus about this, about all windows. It's going to have, and this is going to be under this one struct called Windows Properties. Um, the general consensus is going to have a float width and a float height. SED string title. We can have some other properties like vsync or something else. Right now I'm just focusing on width, height, and title for time being. We can change this later, but I'm gonna take care of the spacing here. Window. So this is our main abstracted window we can use. Um, so this is actually gonna be protected because all classes gonna be accessing this window property. Um, when we initialize, so window, we're gonna have a const window property reference property. And then window property std string constant std string reference title float. I'm not good at that. I'm gonna just put underscores here. It's kind of inverse on what I do. I usually put a underscore representing a private member, but since this is all public, it's gonna be weird. All right, so we have a constant window property, which pretty much starts off a window. We can also do a window. We can also do this too. But anyways, we're gonna have a virtual in it. And function. Oh yeah, for the window property, would also like to know graphics. API. And I'm actually gonna say enum graphics API. Yep. GE graphics token. GE graphics. And OpenGL. Those are so far going to be the two that I'm going to support for now. It could be more or less later on. But, graphics API. So I started graphics API, and there we go. Well, nice to have this, but since I have the graphics API, I'm not gonna do it. And then we initialize, we have an update to window, and we destroy the window. Um, Now the question is, now we need to get a window handle. Gonna use this later. A special tool that I'm gonna use later. But what I'm gonna do, yeah, virtual void pointer get window handle. And that's gonna be a pure virtual function, I think. Yes, it should be a pure virtual here. Making sure everything works here. There we go. Actually, yep, everything works so far. That's good. Um, this is going to be our implement. What I did, what I'm now creating is a implementation folder. This is for like different implementations of our things. So gonna have a window implementation. Start a new class here for our window GLW. Um, and basically up one up to window HPP. I'm actually going to just call 4 since I don't want to do relative path here. Um, yep. Um, I see. I'm not. I need to stop doing that, but whatever. Okay, so now we directly inherited the window class, and we need to implement all the functions here. So window GLFW is gonna have that. Actually, doesn't really matter because they'll inherit, I think. So we need to do it in it. We need to update it. We need to get the window handle. And need to destroy it. So in my source file, I'm going to create a new folder called impl. I'm going to create a new folder in here called window. And then we create a window CPP class. That's right. I need to copy all of that and implement the things. Alright, so GLFW needs a few things to initialize. I'm not gonna worry about that right now, as I still need to implement stuff. Alright, now I can do stuff. Um, so the window has this handle called GLFW window. Pointer window. That's basically going to be our window once we initialize. Um, and yes, when we initialize, we need to do a if do log get logger info starting, yeah. We want to know. So if GFW in it, and if we failed, well, we need to do an SC exit -1. But at the same time, we want to log this. So log.get logger fail to start GFW. If that's successful, then we need to window equals GFW create window, and then it's going to be property with property that height title property title page string null and null. If not window, let's see. Okay. Um, start graphics context. And then that's pretty much it for that, our init end for GLFW. In our updates, we need to, one, clear the buffer, but that's for the graphics context. But we need to GFW all events. And then at the end, we want to terminate. And then return 0. Do we need to destroy the window? I'm gonna say yes. Okay, destroy the window, and that's it. Window glfw.hpp. And here's the errors I'm kind of expecting ish. Oh, right. Well, one, I forgot to include GLFW. I'm gonna include it as just a general. It on my machine, I already have it installed. It's if I create a new tab here. I think it's under user local include. Yeah, it's right there. There's no need for me to like have it in a folder, but it's good if you're like if you do not have this installed. So it's a double-edged sword. But that also means I do not have to include it because it's on the system directory. So yeah. That, so I don't need any of that. All right, get the window handle, and it's just a return window. Does not have any fields called the graphics API. Property. Oh wait, since it's an initializer list. All right, linking errors. Those are fun. So that means I need to go to my pre-make file and then link it somewhere, I think here. Oh, it's in the sandbox. All right. We got our test application working. Now we gotta make sure the window is working here. So in the test application, so about test application we need a window, so this is gonna be in all cases of that. So window application window handle. We're gonna just do a simple include window.http window pointer window. Um, we're gonna implement it in the internet, I think. Yeah, and then the application itself gonna take care of the window. All right, so we just delete the window once we're done, I guess, because we gotta have a window when we start up. So we don't need that, don't need that, don't need that, don't need that. Window equals new. Simple window PFW.http. And then engine 800 by 800 times 9. And then we can do uh simple window. PE graphics broken, for example. I think there's gonna be error in the making, but whatever. We can try it. There we go. No matching function, brace and code list, because we have not implemented that. Oh, right. That's always fun. All right. So we didn't get a window, which is sad. But I think I know why we didn't get a window, because we never initialize. So we have a window. Kind of small, and it's not responding to input. Oh no. Um, oh, I know why it's not responding to input, because we're not in our game loop. We're not listening to that window. So what I'm gonna do is do a should close in the main window. And then this is, we have to implement that in all instances. Google should close constant return gf of w, window should close. So now in our application here, it's running um I'm gonna check if running equals it's gonna be not should close. And there we go. We got window closing. I do want to fix that resolution here. I think I got something wrong here. Sixteen by nine. There we go. As you see, we got a window here. It's taking about 0.000. Very low latency. Since scientific notation. Let's see if I can convert this. That's 6. That many seconds. I think. Yeah. But yeah, we got that going. So that's good. We haven't created context yet. We can do this next time. But I'm going to call this good enough for a commit. Action. Added window. And that's pretty much it. In terms of getting a window started. Um, but anyways, all the changes going to be on my GitHub, or not GitHub, but Git repository. Will be under here. Everything's going to update in next few minutes. If you enjoyed, I guess say something. I don't know. I'm just here coding for fun. If you like it, go ahead and leave a like or subscribe, whichever one. I'm waiting for clout. But yeah. Hope you all enjoyed, and I'll see you all next time.